Um, let's talk function. By definition, a function f is a rule that assigns to each element x in the set x exactly one element called f of x in the set y. We would like to note this is a small letter x and this is a capital letter x. The capital letter x is representing our entire set, the set of x. Okay. Um, we normally represent function notation as what y is equal to what f of x. Okay, meaning our y here, our f of x here is same thing as what y. We say or we read it as what y is equal to the function of x. Okay, on noting our function, I would like us to know that our y is the dependent variable. Our y is a dependent variable, and our x, f of x, is what the independent variable. The independent variable. Okay. Uh, Having known that, uh, I would like us to go ahead with some explanation. Um, I would like to, or I would like us to visualize a function as a machine that receives a particular input, processes it by a rule, uh, and gives out a unique output. But from our definition, I would like us to note some keywords. First of all, a function must be a rule, and each element x in the set x, exactly one element called f of x in the set y. I would like us to note these 3 points. A function must be a rule, each element x, and exactly one element called f of x in the set y. Um, these are the three parameters that define the definition of a function or a function. Okay, we would come to know that very soon. Okay, so I say I would like us to visualize a function as a machine that receives uh, an input and processes it by a rule and gives out a particular or a unique output. Okay, you would agree with me. Um, let's say you would agree with me that the area of a cycle is dependent on the what? Depends the area of a cycle depends depends on what? On radius, right? Uh, the area of a cycle depends on what? The radius. Uh, from the formula we know that what our area is equal to what? Pi r square, where pi is some constant 3.142. Okay, so we could call this as this is a function because this kind of representing our y and this kind of representing our f of x. So why can we call this a function? We note that a function must be a rule. What is the rule guiding this function? The rule guiding this function says that you square the value of r and you multiply it by pi and you get your area. That's the rule guiding this function. Okay, having said that, uh, let's say for example we give r equal to what? 2. What will be our area? Our area will be equal to what? Pi and 2 squared. This is our rule. Our area will be equal to what? Pi, which is some value like I say 1.42 multiplied by what? 4, right? Which is going to give us our area. I'm not with my calculator. um and you know it must give us area, and the area is what? A single value. A single value. um mm, no double no double output. I would like to know this here. No double output. It must be a single value. Okay. Having said that, I would like us to note also two important points uh, when talking about a function. The first point I would like us to notice that element, every element um, in the set X is what is assigned to a unique is assigned to a unique mm, value in the set Y. You would want to note this particular point, and also while talking about function, we would like to know that um, all functions all functions are rules, right? um, but not all rules are functions. This is a very important point to note while dealing with functions. All functions are rules, but not all rules are function. Okay. uh, Let me explain the first point that I'm noting there. For example, I have a set X. Let's say these are our set X, and we also have a set here called Y, and these are the elements in our set X. We have X1, we have X2, we have X3. Yeah, the element in our set Y, we have Y1, we have Y2, we have Y3, and we have Y4. Okay. I would like us to know some clear distinctions about uh, describing a set like this. We call all the values from our set X, we call them our domain, right? Call them our domain. While all the values in our set Y, we call them our co-domain. Okay. All the values in our set Y, they are our supposed images, our supposed images. Uh, but if I map it something like this, we could see that Y4 is being left out, right? So all the values that form the images, which are Y1, Y2, and Y3, uh, they are called the range, of our function. uh, don't mistake the range and the codomain. No, the codomain, everything in the set Y is our codomain, but the values in our set Y, or the elements in our set Y that forms on the images of the set, is called our range, the range of a function. Okay, we could see that from my first point, I say that every element in the set X is our set X. We could see that every element in our set X has a mapping to a particular element in our set Y. Is assigned to a unique. We could see that they are assigned to different unique values in our set Y. So you must note that every element in your set, you can't have a X4 here and you leave it like that without mapping it to this thing. It is not accepted. It must be mapped to a particular element in our set Y. Okay, that was the first point. The second point I would like us to note um, is that what I say all functions are rules, but not all rules are what function. Okay, what do I mean by that? If I have a function f of x equal to what 2x plus 4, this is a function. Why is it a function? Because it is a rule, and because it assigns to each element x in the set X exactly one element called f of x in the set Y. Okay. um if I say my x is equal to what 2, what will be the value of my function? uh my function the value of my function will be what um equal to what 8. If I say x is equal to what 3, what will be the value of my function? The value of my function will be equal to what? 10. As you can see clearly, the value of my function will be equal to what? 10. So bringing out this to our notation, something like this, that means we are going to have our set x and we are going to have our set y. Remember, I said function must be a rule. What's the rule of this function? What's the rule guiding this function? The rule guiding this function says that you should multiply the value of x by 2 and you should add 4 to it. That's the rule guiding this function. And we could see from our calculations that for each value of x, we have a unique value of what? Y. Remember, this is our f of x, which is same thing as what? Y. For each value of x, we have a particular or a unique value of what? Y, or distinct value of y. So noting it like this, we are going to have two sets, and this is our x element and these are y elements. When we have 2 here, we add 8 here, and when we add 3 here, we add 10 here. So this is going to be our mapping. We know this is our domain, and this is our what? Co-domain. We could see that all the values of our codomain are taken, so they all form our range. They all form the range of the function. So we could see that this is clearly a function because it has a rule. There's a rule guiding it, and it's assigning uh, each element x in the set x exactly to one element called f of x, uh, in what? The set y, right? Okay, so this is the first point. Remember, we are still on our point, or the noting point that says that all functions are rules but not all rules are functions. So this is a function and this is a rule. Okay, but let's see another example like this. F of x is equal to what? um, the the half power, or or x to the power of 1 all over 2, which is same thing as what? The positive or the negative of what? X, right? uh, for this function, we could see clearly from here that for any value of our x, we are going to have double values. Is either we have the positive or the negative square root of that value. Okay, let's say for our x is equal to what? 2. What are we going to have? We are going to have our f of 2, which is equal to what? The positive or negative root of what? X, right? Which is same thing, uh, or equivalent to what? uh, Positive x or what? Negative x. So we could see that from here that our function is giving us two separate values for a particular value. So that means this is going to be plus or minus root 2, which is equivalent to plus root 2, or what? Minus root 2. So we could see, if we give another value, let's say 4, right? We are going to have the positive or negative of what? Root 4, which is equivalent to what? Our positive root 4, or what? Our negative root 4. Well, and we know that this is same thing as what? Positive 2, or just 2, and this is same thing as what? uh, a negative 2. So we could see that for every single value of x, we are getting two different values of y, which is not accepted, because according to our definition, we say that a rule that assigns each element of a set x in a set x exactly one, it is being noted, exactly one element called f of x in our set y. But from our function here, we could see that though this function is a rule, what's the rule guiding this function? You should take the positive and the negative root of what? X, right? You should take the positive and the negative root of x. So we could see clearly that though this is a rule, but we can't call this a function. So drawing the map, we have our set x and we have our set y. For the value of 2 and 4, which is our domain, right? And we have separate values. We have on the positive root of 2, we have the negative root of 2, we have the positive 2, and we have the negative 2. So we could see that our uh, domain, which is our set of x, is being two arrows are leaving it, which is not accepted. So we can't call this a function. Though this is a rule, there is a rule guiding this, but we can't call it a function because the function must output a single value. Must output a single value. Okay, that's it.